right, the notes for our first section in Chapter 8 are all about quadrilaterals. So go ahead and fill in today's date up there in the corner. And we'll start with the definition of a quadrilateral. All right, so a quadrilateral is a closed figure with 4 sides and 4 vertices. Down below that box, there are some pictures of examples of what quadrilaterals look like, right here. And then, of course, you've got your pictures of what quadrilaterals do not look like. All right, so closed figure with 4 sides and 4 vertices. So looking at these right here, I've got 1, 2, 3, 4 vertices. And then I've got my 1, 2, 3, 4 sides. That prefix right here, quad, stands for 4. So it's a 4-sided figure. All right, let's move down here to consecutive sides and vertices. Consecutive should be a familiar term for us. Consecutive means right next to each other. We've talked about consecutive sides for triangles when we've worked with side, 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 and angles as well for that. So the consecutive sides, I will highlight those for you. In this figure are PS right here, and then SR. So they're right next to each other. And then the example of non-consecutive sides here would be this PS and then QR. So they're not right next to each other. They don't share that common vertice. The vertices, like we've talked about with triangles, are those corners of the quadrilateral. So we have 4 vertices here, vertice at angle P, angle Q, angle S, and angle R. All right. Moving down to diagonals, that's a new term for us. So I'm going to go ahead and highlight that for you. That diagonal is a segment that connects 2 non-consecutive vertices. So again, consecutive means right next to each other. So we're talking about vertices that aren't right in a row here. So the example that they have given for us here is a diagonal from the non-consecutive vertices of S and Q. So that diagonal is right there. In a quadrilateral, we have 2 diagonals. I'll go ahead and highlight that other diagonal. The other diagonals from those other non-consecutive vertices of P and R. That would be this diagonal. And we would call that PR segment. Is also a diagonal here. Okay. Let's move on to the next page. I'll make this a little bit bigger for us. So we're going to be looking at an example here, and we're going to be naming consecutive angles and non-consecutive vertices here. So the first one is naming all the pairs of consecutive angles. And again, just a reminder that consecutive term means right next to each other. So our consecutive angles, I'll start with A. So angle A, and then I'm going to go up here to angle B. I'll just keep going around my quadrilateral here. Let's erase those. Next one, I'm going to go from angle B and then angle L. Okay, I'm going to keep that circle on angle L, and now I'm going to look at angle L and angle E. And then I'll go ahead and look at that last one here. The next pair of consecutive angles is angle E and angle A. Again, we just went around that quadrilateral and named the angles that were right next to each other, consecutive. All right, so the non-consecutive vertices, those are the vertices that are going to be not right next to each other, or in a case of a quadrilateral, across from each other. So I will go ahead and start with angle E here. Angle E its pair for its non-consecutive is angle B. Let's fix that. And then I'll go with the other two. I'm looking at angle A and angle L. Okay. The letter B there, those answers are going to help us name our diagonals. I will go ahead and draw those in with my highlighter here. So from angle A to angle L is one diagonal, so I'll name that segment AL. And then the other diagonal here is going to be from E to B, angle E to angle B, and I will name that segment BE. Okay. Now moving on to more of their quadrilateral definitions here. The quadrilateral sum, and it states that the sum of the measures of the angles of a quadrilateral is 360 degrees. Now if we think back to our triangles, I'm going to draw a four-sided figure here. And I'm going to split it up into two different triangles. And what we already know about triangles is that they have their interior angles add up to 180. So if this triangle on the top right of this rectangle is 180, and then this bottom triangle interior angles add up to 180, we could then conclude or kind of see how if I've got a quadrilateral, so that four-sided figure, the sum of their angles, so the four angles that make up that quadrilateral here, add up to 360. So kind of building on what we know about triangles there. All right, now let's do an example here. Finding the measures, missing measures of the quadrilateral. And again, we just learned that the sum of the angles of the quadrilateral add up to 360. So I'm going to go ahead and mark my 90 degrees. Oops, it's not a very good 90 here. Mark my 90 degrees here, and I've got 90 degrees here, those two right triangles there. So right now, and when we're working with quadrilaterals, since we've got four angles, we are going to have one angle plus another angle plus another angle plus another angle equals that sum of 360. So when we're setting up our equations here, we're going to give us our four blanks, and then we're going to fill that in. So looking here, I've got a 90-degree angle, and then I've got another 90-degree angle. I've got a 50-degree angle, and then I've got my angle A, which I'm trying to solve for here. First thing I'm going to do then is combine my like terms. Again, my like terms are right here, those three numbers that are alike. So 90 plus 90 plus 50 gets me to 230. Bring down this plus A equals 360. Then we're going to use our algebra skills then to solve for A. In order to do that, I'm going to subtract 230 from both sides of my equation here, and I get A. Oh, I didn't write. Helps if I write 230. Subtract 230 from 360, and I get A is equal to 130 degrees. Right there. So that's how we find the measure of angle A. We would set up that equation, give yourself some blanks like we did with our triangles. Angle 1 plus angle 2 plus angle 3 plus angle 4 is equal to that 360. All right, let's move on to our next example here. Find the missing measures of find the missing measure if 3 of the 4 angles in quadrilateral A, B, C, D are 50, 60, and 150. And again, what we just learned was that the measures of the interior angles of a quadrilateral add up to 360. So I'm going to set up my equation. 50 plus 60 plus 150 plus that 4th angle, I'll call it x, and again we know they add up to 360 degrees. I combine my like terms here again. My like terms are that 50, 150, and 60, so that would be 260 plus that x is equal to 360. We're going to use our algebra to solve for x. Subtract 260 from both sides. I've got x is equal to 100 degrees. So that 4th angle would be that 100 degrees right there. And again, that was just setting up what we know about quadrilaterals there, or interior angles of a quadrilateral. Oops. All right, and our last one here, we've got find the measure of angle U in quadrilateral KDUC if we know that the measure of angle K is 2x, measure of angle D is 40, and the measure of angle U is 2x, and the measure of angle C is 40. So I'm going to go ahead and give me some letters here, KDUC. And I know that the measure of angle K is 2x, the D is 40, U is also 2x, and C is 40. So again, we're going to set up our equation that we know the interior angles of that quadrilateral add up to 360. So I've got 2x plus 40 plus 2x plus 40, and again we're going to set that equal to that 360 that we know. I've got 2 different like terms here to combine. I've got my x terms and I've got my numbers here. So 2x plus 2x gets me, so let's not put the highlighter back. 2x plus 2x gets me 4x. 40 plus 40 is 80. Again, 360, nothing's changed over there. Working with our algebra, in order to solve for x, I have to get this x by itself, so I'm going to first move that 80, so I'm going to subtract 80 from both sides here. It's going over here, so now I've got 4x is equal to 280. And then that last step would be to divide both sides by 4, and I've got x is equal to 70 degrees. Now, looking back at that question, it's asking us to find the measure of angle U. So I see measure of angle U is equal to 2x, so I'm going to use that x is equal to 70, and measure of angle U is equal to 2x, so I'm going to put in that 2 times 70, so I know that the measure of angle U is equal to, oops, that should be a 70. Measure of angle U is equal to then 70 instead of that. Measure of angle U, I could finish this for you guys. Measure of angle U, oops, make that, is equal to 140 degrees. So again, quadrilaterals are four-sided figures with four-sided closed figures with 4 vertices and 4 sides. And we also learned today that the measure of the interior angles is equal to 360 degrees. Your assignment is listed right there. You have it on the next page of your packet. Go ahead and complete that.